Okay, let's get started. I'd like to thank everyone for joining us today. Welcome to today's CNCF webinar, Cluster API, Yesterday, Today, and Tomorrow. I'm Jerry Fallon. I'll be moderating today's webinar. We'd like to thank our presenters today, Saad, Malik, CTO and co-founder of Spectral Cloud, and Zhou, Chief Architect at Spectral Cloud. Just a few housekeeping items before we get started. During the webinar, you are not able to talk as an attendee. There is a Q&A box at the bottom of your screen. Please feel free to drop your questions in there and we'll get to as many as we can at the end. This is an official webinar of the CNCF and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of the Code of Conduct. Please be respectful of all of your fellow participants and presenters. Please note that the recording and slides will be posted later today on the CNCF webinar page at cncf.io/webinars. With that, I'll hand it over to Saad and Jin to kick off today's presentation.
Thank you, Jerry. Hi, everyone, and thank you for joining our webinar. My name is Saad Malik, and I'm the CTO and co-founder for Spectral Cloud. So a little intro about me. I'm the guy who likes to build and tinker with new technologies, especially in the areas of Linux, virtualizations, and containers. I started off my career at Cisco as a full stack engineer back when building web applications using JSP pages and MVC platforms like Apache Struts was considered in style. And from there, I went on to join a cloud startup called Clicker Technologies. At Clicker, we focused more on the multi-cloud application management across multiple clouds, including private clouds and bare metal. And that's actually where we first started working on Docker containers and using container orchestration platforms like Apache Mesos and the early versions of Kubernetes. So Clicker was acquired by Cisco in 2016. And by then we started seeing firsthand how quickly the world was changing, where organizations and enterprises across all verticals were transforming themselves to become technology-first companies. Again, to offer best-in-class customer experiences via applications and other digital mediums. So many of these organizations went through rapid adoption of new technologies and toolings, such as clouds and containers, Kubernetes, but they also had to embrace a significant mindset shift to adopt a DevOps culture where teams were being more agile and free to choose the technologies that they wanted to. So these changes did not happen overnight. And as you can imagine, it still continues to be a complex undertaking. Many enterprises choose to run in a hybrid cloud environment where legacy applications or data-sensitive applications may run on-premise, but opting to run other workloads on a public cloud. So we witnessed these complexities and challenges organizations were having in adopting Kubernetes, not just with provisioning, but day 2 management and more operationalizing it in terms of monitoring, logging, security. So myself, along with 2 other VPs, one was the co-founder of Clicker, the other one was VP of engineering at Clicker. We left 18 months ago to start Spectral Cloud to focus on providing a SaaS platform to simplify the experience of running Kubernetes clusters in production by giving enterprises the flexibility and control and consistency they need without giving up the ease of use and manageability at scale. So with that, hand it off to June.
Thanks, Saad. Hello, everyone. My name is Zhou. I'm the Chief Architect and Founding Engineer at Spectral Cloud. I've been working with Saad since the Clicker days. So when Clicker was acquired by Cisco, I built the Kubernetes management platform for Cisco Cloud Center. And when Saad co-founded Spectral last year, I joined him from the day one. So today we are going to talk about the popular tools to install and manage Kubernetes before Cluster API released, and then dive into Cluster API and briefly touch on the Cluster API CRD models. And then we'll look at the enterprise requirement for Kubernetes management and what it could be possibly built on top of Cluster API to achieve those. So there are the tools that we'll cover today. We'll start with the kube-up script, which is the part of the Kubernetes source code, and go through kubespray, kubeadm, kops, and then to Cluster API. From the time of the first release perspective, kubespray was released pretty early and not long after Kubernetes GA release. And then 1 year later, kubeadm and kops were released around the same time. And only until last March, Cluster API had its first release. So kube-up is the first available tool to bring up a Kubernetes cluster. It uses command line tools like AWS CLI or gcloud to prepare the cloud infrastructure, then launch the virtual machines to form a cluster. And after that, critical add-ons like CNI and DNS are installed. The actual Kubernetes component configuration is done by salt stack. So the master node will run a salt master, and all the nodes will run the salt minion. So the salt minion contact the salt master with the machine information, and the salt master will provision the VM to be either a Kubernetes control plane or Kubernetes worker. So from this 1.0 release snapshot, we can say it already supports like all 3 public clouds, as well as vSphere. And for operating system, it's mainly Ubuntu and CoreOS. And actually, my first PR to Kubernetes is actually within this kube-up shell script in 2015. So for GCE, the kube-up script will build a user data, which contains the complete salt configuration for both the master and worker. So no matter what the VM is, right, whether it's a control plane node or worker node, the user data is the same, and it contains both information. And then based on the machine identity, the local salt will configure itself without contacting the salt master. And unfortunately, the user data for GCE exceeded the size limit. And we were trying to strip out like all the comment in the user data script to make the size small enough. The 1.3 release of Kubernetes in June 2016, we can see that the list goes longer, adding more providers and more OS support. But actually from this release, kube-up script already entered maintenance mode. It will not accept any new providers. And now if we check the latest code, most of the providers already got deleted and only GCE is there. And the first available tool, I think the script is always easy to start with, but very soon the community realized that we need a proper installer solution because the Kubernetes becomes so complicated. And around like 3 months after kube-up enters maintenance mode, in the next 1.4 release, kubeadm was announced. And kubeadm simplified the cluster bootstrapping to literally just 2 commands. You do kubeadm init on the first control plane node, and then kubeadm join on rest of the node. So internally, as a command line tool, kubeadm divided the whole setup process into different modular phases, with most of the phases can be reused in different life cycles. The kubeadm init does most of the job. It'll bring up a single node Kubernetes cluster. Internally, it first validates and prepare the node, will generate the certificate, will generate the manifest for the static pod, and then start control plane component like API server, controller manager, scheduler, and etcd to bootstrap the first control plane node. Then when the first control plane node is up, it will generate additional information for future kubeadm join, like the bootstrap token, and it will also store the shared CA certificate into the API server, so other control plane nodes can directly download from there. Then in the end, it will install the core add-ons like DNS or kubeproxy. The join can happen both for control plane and workers. Join the control plane node will prepare the certificate and then start the control plane component and join the etcd cluster. And join the worker node is relatively simple. It will just start a kubelet and register to the API server. Kubeadm support like multiple HE topology. And the main difference between the two is the etcd cluster. it can start a static etcd pod on each of the control plane node, then join them together to form a stacked etcd cluster. Or it can also support to use an external etcd cluster if we already have one. And all the worker node, the kubelet, they talk to the API server through this external load balancer. So kubeadm has very focused scope, and part of the philosophy is to do the minimum and do the best. After kubeadm was announced, it became the de facto tool to do cluster bootstrapping and was adopted by many other Kubernetes management tools. While at the same time, creating a Kubernetes cluster needs a lot of other tasks while the kubeadm does not cover. For example, infrastructure management is not there. You need to provision the host with the infrastructure networks and the storage. And also it will not manage add-ons. Either it's critical ones like a CNI or storage class, or non-critical ones like a logging or monitoring. And also for cloud provider integrations, like if you want to utilize AWS ELB for the load balancer service, that integration between the Kubernetes cluster and AWS is not directly managed by kubeadm. So we can see that kubeadm cannot provide an end-to-end solution alone. It positions itself as a building block for higher level orchestration tools. So that was the kubeadm. The next tool we want to talk about is kubespray. Like I mentioned, kubespray came out quite early, only a couple months after Kubernetes GA release. And if you look at the docs, it can support deployed to anywhere using any OS, like all the public and private cloud, as well as bare metal. And it can also support all the common Linux distribution and different versions. But this is great by looking at the supported list. It covers all the different combinations, but it also comes with a big price. It's a non-managed infrastructure. So for kubespray, the philosophy is bare metal first. For all the features, it will get to work on bare metal first, then consider the support on other cloud. Internally, it builds on top of Ansible using OS-centric way to do the configuration. So you need to launch your own VM with your own OS, and kubespray will SSH into the host and do the configuration for the Kubernetes component. Because of the bare metal first philosophy, kubespray tried to avoid any external dependency. For example, for kubeadm HE setup, it will need an external LB on top of the control plane node for the API server endpoint. But kubespray can support a partial HE setup without external LB through the concept of a local host Nginx proxy. So basically what it does is all the worker node, the kubelet will talk to a local Nginx proxy, and this Nginx proxy will distribute the traffic to all the control plane API servers. But the component on the control plane node, like the kubelet and the controller manager and the scheduler, they only talk to the single API server on the local host. And also the API server endpoint for the client that's outside of the cluster is only to the first control plane node. So if the first control plane node is down, even though the cluster is still running and all your application is still running within the cluster, but all the client outside of the cluster is not able to access the API server. For example, if you want to do a kubectl from your laptop to this cluster, it's not going to work because the first control plane is down. So kubespray was released before kubeadm exists. So initially, it had its own ways to configure all the Kubernetes components to join the cluster. And later on, when kubeadm became mature, kubespray started to use kubeadm as the tool to do the cluster bootstrapping. And in addition to kubeadm functionality, kubespray add other functions to make the cluster ready to use once it finishes. Like it will install critical add-ons like CNCF. It can help you integrate the cloud providers to utilize the cloud features like ELB for your load balancing service or EBS for your persistent volumes. It has a good support for environment, either behind the proxy or pure air-gapped setups. But the big part missing here is still the infrastructure management. So if you already have other systems to manage your infrastructure, kubespray is a good option to only do the Kubernetes configuration. With that, we come to Kops, and quite different from kubespray. Kops' philosophy is cloud first. The goal was to cover all the aspects to provide an end-to-end solution, including infrastructure setup, Kubernetes configuration, and add-on installation. It has deep integrations with cloud features. For example, on AWS, it integrates with Route 53 for DNS, use auto-scaling group to launch a node, ELB for your load balancing service, and EBS for volumes, and KMS for etcd data encryption, S3 for the cluster configuration, and IAM for authentication, and also the cloud features. They have deep integration. And for a long time, Kops has the best support for AWS. And now there are more cloud support like GCP, OpenStack, and DigitalOcean are all there. So some of the features I feel are quite unique in Kops. The first one is the DNS. For Kops, DNS is a must-have. And all the control plane node, they have static DNS names. So instead of directly using IP to communicate, with the DNS, the benefit is all the control plane nodes have a static identity. Then similar to Kubernetes default set, you can replace control plane nodes without losing the identity. And initially, Kops require to have an external DNS with a valid domain name, but later on, the gossip DNS is added, so no external DNS is required. For etcd, Kops have separate volumes for the main data and event data. So you can manage those data differently if you like. It also supports etcd auto backup and support etcd data encryption. The other thing which is quite unique is the auto-scaling group. So Kops does not directly launch VMs. It creates auto-scaling group, then relies on the cloud to auto-launch the VMs. And these, together with the static DNS identity and etcd volume, makes the system auto-recover possible. If you terminate one of the control plane node, it can auto-launch a new one, attach the existing etcd volume, and join the cluster without changing any other configuration in rest of the node. You can even terminate all of the control plane node, and when needed, just scale up the auto-scaling group, which will still have all the existing data because the DNS is still there and your etcd volume is still there. Apart from this, it can generate Terraform compatible configurations. So if you are using Terraform to manage your IT system, you can easily plug it in. And it can also help integrate with like other features like horizontal pod auto-scaling and AWS IAM Authenticator and others. In order to provide an end-to-end solution, and remember Kops was also developed before kubeadm exists. Right? It built a lot of internal tooling to make this happen. For example, all the cluster configurations are stored inside a state store, which support using S3 or Google Bucket, or even file system at the backend. The image builder project was used to prepare the base image for Kops. And NodeUp is the first running component inside of the VM launched by Cloud Init. it will install Docker and Kubernetes and other dependencies directly into the host. And then it will install ProtoKube, which starts the next stage of bootstrapping. The ProtoKube will generate the manifest for static port and attach etcd volumes to the control plane node. Then DNS controller is managing the cluster DNS functionalities like gossip DNS, and etcd manager is managing the etcd cluster as well as data backup and etcd encryption. So this is a topology of Kops cluster on AWS using private subnet. And we can see Kops can provision a new VPC and set up all the subnet, the NAT gateways, ELBs, and all the infrastructure component. And for the control plane node, within each zone, it is using a separate auto-scaling group. And because of the etcd volume, you cannot attach a volume to a VM in a different zone. And for workers, it is managed within one single auto-scaling group across multiple zones. So Kops is widely adopted, especially for the clusters on AWS. And there are still some desirable improvements that we can talk about. First of all, as a CLI-only tool, once the Kops finish running, it's done. So it totally relies on the cloud features to bring up the cluster. It can achieve some level of auto-heading by using auto-scaling group, but some of the other issues it may not be able to cover, like some bootstrapping features. So the node come up fine, but not able to join the cluster. Those kind of features, Kops is not able to auto-recover. And secondly, Kops bundles with fixed versions of critical add-ons. So if you want to use another different version for your CNI, it's not directly supported. And there's no bare metal or vSphere support as of now. There was some experimental support previously, but it was already deleted from the latest code. And lastly, Kops release lag behind the upstream Kubernetes release. For example, the latest Kops release 1.17 was released on end of May, and the upstream 1.17 was released last December. So there's around like half a year lag behind. With all the tools, we can say these are the challenges that the installer tools need to address. And first of all, we need to set up the infrastructure to run Kubernetes, either in public cloud, private cloud, on-prem data center, or edge locations. And each of those environments have a very different setups in terms of networking or storage. Then it is operating system with all the different Linux distribution, different versions, or even Windows system. It also needs to handle continuous OS update, security patches. And then when we have the host running, to actually bootstrap and configure the cluster needs a lot of domain expertise. For example, do you want a cluster with a single master or HA? How do you want to manage the etcd cluster? It is stacked with the control plane node or live outside of Kubernetes. And how to plan for feeder domains to maximize your system availability. And also for each of the Kubernetes component, like API server, controller manager, there are hundreds of configuration options. And you may also want to know what are the best practices for security. Do you want to enable audit log? How to set up security policies? And all those different questions need real Kubernetes expertise. And then once we have the cluster running, there are still tons of additional integrations that need to be configured to get a real production Kubernetes cluster, like the authentication, logging, monitoring, security, etc. And once you finish all the integration setup, this is just the beginning of the journey. Kubernetes has a new release every quarter, and together with the bug fixes and the security patches coming out literally every week. So the day two management need continuous effort across all the different stages. And once more, this is just one Kubernetes cluster management. Imagine if you need to manage tens or hundreds of clusters altogether. With all these challenges in mind, let's take a look at Cluster API and how it plans to address those challenges. The main goal of Cluster API is to use Kubernetes to manage Kubernetes, using Kubernetes declarative API model, leveraging CRDs and customer controllers. The project started in early 2018 and currently is in V1 Alpha 3 stage with more than 200 contributors from the big companies. And it has a long list of supported cloud providers. It covers most of the public and private cloud environment, as well as bare metal. Here we'll briefly go over the Cluster API CRD models here. There was another CNCF webinar last month talking about the details of Cluster API architecture, and feel free to check it out. Cluster API is built using customer resource definition known as CRD. So CRD is the way of extending Kubernetes declarative API model to manage pretty much everything. Like CRD defines the desired state, then the customer controllers will keep reconciling, trying to bring the resources to the desired end state. If we take a Kubernetes cluster at a CRD, the CRD will just include information like which cloud environment, which Kubernetes version, how many master nodes, how many worker nodes. Then the customer controllers running in a management Kubernetes cluster will just continuously trying to launch a node, bootstrap the node, join the node to the cluster, and eventually bring up the Kubernetes cluster in the target environment. This works the same way how Kubernetes is managing pods and containers. The difference is instead of talking to Docker or containerd to create a container, these custom controllers talking to the cloud API, like EC2 or vSphere, to create virtual machines and other infrastructure like VPC and load balancer and all those. So let's take a deep look at the Cluster API CRD definitions. What are the CRDs needed to represent a running Kubernetes cluster? I think first of all, of course, we need a cluster CRD. And a cluster is composed of a group of nodes. So we need a CRD for the node as well. And actually that's the two fundamental CRDs Cluster API has, the cluster and the machine. To make the system work across all the different cloud environments, Cluster API has additional cloud-specific CRD for both cluster and machine. For example, the AWS cluster contains information like region or VPC, and AWS machine contains information like instance type and AZ for each of the VM. Apart from the underlying infrastructure VM, we still need information to represent how to configure those VMs. And that's where kubeadm config come into picture. It will generate user data, which contains kubeadm bootstrapping command, like either kubeadm init or kubeadm join. Then utilize cloud init to do the bootstrap when the VM is launched. So technically, with cluster and machine plus kubeadm config, we are able to create a Kubernetes cluster. We need to create one cluster resource and one machine resource for each of the nodes that you want to launch. And create a machine resource one by one is going to be difficult if you want to have like hundreds of nodes in the cluster. To solve this problem, on top of the machine CRD, Cluster API also provided two higher level CRD to manage control plane and workers separately. kubeadm control plane is used to manage control plane node, handles functions like kubeadm init, certificate generation, etcd membership management, and also upgrade and scaling of the control plane node. And machine deployment is modeled after pod and application deployment to provide the ability to bring up a pool of worker nodes with the exact same configuration. This is all the CRs needed to create a Kubernetes cluster on AWS. So the first half are the resource user need to define manually. You define the cluster resource together with the kubeadm config template and also AWS machine config template for both the control plane nodes and workers. Then the controllers will auto-generate the actual machine object from the template information. And once the machine joins the cluster, it will have a one-to-one mapping to the Kubernetes node object. So this is the deployment architecture for the cluster on AWS launched by Cluster API. So it looks quite similar to what a Kops does. Although some of the difference like a DNS setup, etcd volumes, those are not shown here in the picture. But one difference from Kops is Cluster API directly launch VMs, but Kops using auto-scaling group to create VMs. Well, actually for the worker node, Cluster API support auto-scaling group as well. So instead of a directly managed VM, it can use auto-scaling group to launch a group of nodes. But that feature is not supported in all the cloud yet, and it only supported for worker node, not for the control plane node. But the control plane node is still directly created VMs in the cloud. Here are some of the main features in Cluster API roadmap. The version 0.3 was released in March, which added the kubeadm control plane support. So before 0.3, you need to manage the control plane node directly using machine object. Then all the upgrades and scaling is kind of difficult. But with the kubeadm control plane added, it handles all the control plane node management, similar to how machine deployment does for the worker nodes. Some other big features coming up are like auto-scaler integration and spot instance support, and also like pre-delete hooks for machines, and cluster resource set, which is used to help install critical add-ons like CNI. And actually, this was the previous roadmap. The community is now doing V1 Alpha 4 planning, with most of the 0.3x features will be mainly like bug fixes, and the new features will be all moved on to 0.4. So we've talked about Kops and Cluster API. Here is a compare between those two in terms of the challenges that need to be addressed. For the different cloud support, Cluster API, I think, is a winner, as Kops does not have on-prem and bare metal support yet. And Cluster API covers most of the cloud environment as well as bare metal through its cloud provider plugin architecture. For the operating system, Cluster API mainly support Ubuntu 18.04 and CentOS 7. Kops have more OS support. What's mentioned here is they took a different approach to manage the operating system. So Kops use a minimum configured OS as the base image. Then the bootstrapping tool will dynamically install the dependencies like Docker and Kubernetes into the VM on the fly when the VM is up. But Cluster API pre-build all the dependencies into the image itself. I think there are pros and cons for both approach. When we pre-build all the dependencies into the image, that means for all the upgrades, you will need to make a new image with the newer versions of the Kubernetes and kubeadm and all those. And today, Cluster API release images for all the versions for all the main cloud. But if you want to use your own security hardened OS or install any additional libraries, then you will need to manage that separately. On the other hand, if you dynamically install the dependencies on the fly, then there are risks that things working perfectly fine yesterday may stop working today. Excuse me. So for example, last month when Kubernetes 1.18.4 was out, it tried to decouple the Kubernetes CNI library from kubelet. And then the new YAM packages released caused issue for all the older versions of the Kubernetes install on CentOS. So basically YAM install kubelet will fail. And it took 1 whole week to fix the issue. So if you're trying to install kubelet on the fly when the node is up, for CentOS, you are going to run into issues for like a whole week. So things like that doesn't happen often, but it can still happen in the future. For bootstrapping, Cluster API use kubeadm internally, but Kops use its own equivalent called ProtoKube. Both are doing similar things. For integration, Kops bundles with fixed versions of critical add-ons like CNI, while Cluster API, the latest release, just added the cluster resource set, where you can include YAML files for the critical add-ons like CNI. So it will automatically install that for you, but you still need to prepare those YAML files. For day 2 management, I think both support upgrade and Kops have additional features like etcd backup and restore. And multi-cluster management, the Cluster API can manage multiple clusters from a single management cluster, which makes it a little bit easier. But for Kops, each of the cluster is managed separately. As we can see, they are doing similar things, and each of them have something that the other one does not have. So what if we combine them together? So this diagram is actually from KubeCon talk from the Kops founder. It's not surprising that Kops team already thinking about the integration with the Cluster API. Actually, Kops and the Cluster API, they use the same image builder project to manage the base OS image for both projects. With the Cluster API integration, Kops can cover more clouds and can move to an operator pattern to do the reconciliation to auto-recover more features. At the same time, it can still keep the good features like DNS, static identity, etcd management, and all those. And for add-ons, there are plans to have a separate controller to manage add-ons. So they are not statically bundled with the Kops with a fixed version. So with this integration, it looks perfect, right? But it needs to automate Kubernetes management tools. Is there anything else that needs to be done? With that, I'll hand over to Saad to talk about enterprise requirement for Kubernetes management. Saad, please.
Thanks, Jun. So before we start thinking about the capabilities, a higher level orchestrator, we need to identify some of the responsibilities organizations have when it comes to managing and operating a Kubernetes cluster. So there are at least 4 large key areas that infrastructure and operations teams need to be aware of and responsible for. In the first bucket, security, right? The aspect of keeping not only your base operating system, but your base container images up to date and secure, right? In the cloud, you might have a managed Kubernetes provider that provides an out-of-the-box security hardened image, but if you're dealing with hybrid cloud or multi-cloud, or if you need, like Jun mentioned, you need to bring your own libraries or support inside your operating system, then you have to be responsible for it. I would recommend, on a regular basis, run a CVE scanning tool like Vaults. And for container images, you might be using something like Trivy. But in the practice of keeping more security aspect, Google also publishes a distroless image. And these distro-less images are relatively very small images, it's a couple of megabytes, which don't really have a big security exposure. Other aspects in security, of course, deals with how do you secure ingress access into your clusters. You can implement network security policies in Kubernetes. Ideally, you would do it both for inter-service communications, but at the very least, do it for your north-south communications. For public cloud environments, there is a service type of load balancer where you can specify a load balancer source range. And essentially, if you specify that, you limit what are the actual inbound security rules of how access happens into your clusters. Moving on to configuration management, especially for organizations that have larger multi-tenant clusters, right? There needs to be a strategy in place for managing your namespaces and assigning the appropriate resources to the various teams that are using the clusters. If you're dealing with multiple namespaces, there is a really cool tool called Kiosk, which in a way essentially automates the lifecycle management of different namespaces for different teams. And I do want to call out in this specific section that more and more teams and organizations are moving to a GitOps model, where they're maintaining their application workload manifest, they're maintaining their custom resources and other configurations in a Git repository, and then using a tool like Flux or Argo CD to automate the rollout of this configuration to their clusters. How do you provide logging, monitoring, and tracing support, not only for your infrastructure platform, but also for your application workloads, right? Most organizations do run a central logging and monitoring platform, and they'll use tools like FluentBit and others to essentially pipe all their logging and monitoring into the central clusters. And on the business continuity side, right, how do you provision and maintain your high availability for your control planes or all the components that you mentioned? And also on top of it, doing things like backup and restore and snapshotting of your control planes. And as the updates happen, right, how do you ensure that you don't get any impact to the availability of your applications? Next. So looking at some of the requirements of what would it mean to have a higher level orchestration, right? There are at least three key areas. One is on the ease of use, right? The other is manageability and flexibility. So Cluster API itself is an extremely powerful tool. It makes it really easy to provision and maintain your Kubernetes clusters. However, there is a steep learning curve to understand how to use it. And like June mentioned, you're not gonna just use Cluster API by itself. You will have other pieces of technology you work with it. As an example, if you are building your own operating systems and maintaining your own versions, you will probably automate it using something like Packer. On bare metal systems, you might need to integrate it with iPXE booting and Redfish APIs. What if there could be a higher level orchestrator that combines the best of these technologies, right? And provides a simpler API for users to be able to consume and utilize this system itself. The cluster APIs and many of these technologies that I mentioned are moving very fast. V1 Alpha 3 had some breaking changes, same with V1 Alpha 2. And it's expected, as there's more and more functionality coming in until it becomes stable, there's gonna be more changes. A higher level orchestrator, right, just by definition, could simplify and keep the actual APIs for end users very consistent, even if the underlying technologies are changing. So at scale, as you start having more clusters, how do you monitor the health and status of your clusters, right? While also ensuring that your latest security patches and configurations are applied across all your clusters. Potentially a higher level orchestrator can build these functionalities into it, do reporting and alerting built into the platform. And doing all of this flexibly across any cloud of your choice, whether you want to bring your own OS images or whether you want to use the one the cloud provides with your own integrations. Next, please. So here are just some of the possible high-level features that a higher-level orchestrator can provide. Everything from namespace management to providing capabilities for quota control and compliance, right? Backup restore is a huge area. All of these things are very differentiating features that not a single platform today, all of it has. But one of the key proponents of what we're discussing today is all of these higher level orchestrators should be built on top of Cluster API and potentially Kops. Because doing so, you leverage all of the work the community is doing. Today, I believe there are 14 different public and private cloud support already in Cluster APIs, with more being added. Day in, day out, there are new functionalities exposed from these cloud providers in terms of new ways of doing load balancing and new ways of doing security groups. All these capabilities are being added into Cluster API. And if these higher level orchestrators were sitting at a layer on top, they would essentially be able to leverage all the work the community is doing and still being able to provide values that are needed for their customers. Next, please. So this may or may not be part of the responsibility for a higher level orchestrator, right? But it's important to call out. Kubernetes itself is just an open source technology. It does simplify the lifecycle management of application from deployment, scaling, service discovery, resiliency, many different aspects. But as we've discussed, there are many other areas and capabilities needed to run a Kubernetes in production. Right? Think from monitoring, logging, security, ingress, all these different areas in some ways are needed to be integrated. I think one of the hallmarks of Kubernetes is not boiling the ocean, but building all of these capabilities into itself. And instead, it allows a healthy and thriving ecosystem of vendors and partners to provide solutions for logging, monitoring, and security. Each of these different buckets you see will have tens and tens of options and different choices. Some of these choices may work for majority of enterprises, and there's other choices which may work for very specific use cases. CNCF today has over 1,400 components and technologies in its landscape, and this list will only grow over time, right? So one of the questions that we generally get asked is, how do you find these integrations? I think the best option, of course, is participating in the community, participating in webinars, especially these end user webinars where companies are talking about their choices they made as it did from the CI/CD pipeline to provisioning of their clusters to how they're security and monitoring these clusters. CNCF also recently introduced a CNCF technology radar, which provides tools in different categories of what the recommendations are, whether it's for security or whether it's for AI ML building software. Take a look at the technology radar to see what are some of the recommendations that the community at large is giving. And again, like I mentioned, stay in touch with the community, figure out what's going on, and stay connected with KubeCon and events like those. So that pretty much wraps up the portion that we have. Were there any questions? And one more aspect too, if you want to continue talking with June or me, please continue the conversation at spectracloud.com. And please feel free to join our community at slack.spectracloud.com.
Awesome. Thanks, guys, for a great presentation. It looks like we have one question here from Jindong Lee. Newbie question, what other APIs are there as an example in relation to cluster APIs?
June, other APIs? Yep.
If I understand correctly, the question was trying to ask if there is any other like similar tooling trying to use the CRD to manage Kubernetes cluster. So if I understand correctly, this is a question, and I think the answer is no. Right now, the community put I think most of the effort into the Cluster API project, and it is pretty active with all of the different contributors from the companies like VMware, Google, Red Hat, Microsoft, and also many startups also contributed to the project as well. And it's pretty active, and I think I'm not aware of any other similar project doing the same thing.
Any more questions at all? Okay. Well, thank you guys for a great presentation. And I want to thank everyone for your time today. The webinar and recording will be available later today on the CNCF website along with the slides. Thank you again for joining us and have a great day.
Cool. Thank you so much, guys.
Thank you.